You know, the idea of building a city on Mars, it's one of those things that just completely captures the imagination, right? But what's the reality of this multiplanetary dream?
I mean, listen to this. This paints a pretty bleak picture. But is it true? Is it just hype? Let's actually break this down claim by claim and see what the science really says.
All right, so let's get right into it. We're going to tackle these 5 big claims one by one and really see if they hold up. Okay, first up, the cold. Is Mars really colder than Antarctica? Well, the answer is a huge, resounding yes. I mean, look at the numbers. Antarctica has the record for the coldest day on Earth, sure, but on Mars, the average temperature is a bone-chilling -60°C. And if you go to the poles, it plummets to -130. So yeah, no contest there.
All right, what about dryness? Is Mars drier than the Sahara? Oh, absolutely. It's not even close. To put it in perspective, the Sahara, which we think of as the driest place, has hidden underground water. It would basically feel like a lush tropical paradise compared to how bone dry Mars actually is.
And the air? What about the claim of no air? Well, okay, technically Mars has an atmosphere, but it's so incredibly thin. We're talking less than 1% of Earth's pressure that for us, it's basically a vacuum. On top of that, it's 95% carbon dioxide, which you can't breathe. So for all practical human purposes, the claim no air, yeah, that's pretty much spot on.
So what about the soil? Is it toxic? Yeah, I'm afraid so. The Martian dirt is full of these things called perchlorates. These are nasty chemicals that are toxic to humans, and they would poison any crops we tried to plant. You'd need some serious, heavy-duty processing to make it work. So that's 4 for 4 on the hostility checklist. And that brings us to the big one, the most dramatic claim of them all, radiation. Is it really true? Could 1 hour walking around on Mars really give you a full year's dose of radiation?
Well, the short answer is no. That's a massive exaggeration. But, and this is a huge but, just because that specific claim is wrong, it doesn't mean the problem goes away. The reality of radiation on Mars is still one of the biggest hurdles we face. So let's actually look at the real numbers. Okay, so this chart really lays it out. On Mars, you're looking at an average daily dose of about 0.67 millisieverts. Now compare that tiny little bar for Earth's average. The difference is just huge. So no, you don't hit your yearly limit in 1 hour, but you would hit the annual radiation limit for a member of the public in just a little over a month. A month! So here's the key takeaway. The background radiation on Mars is roughly 100 times higher than what we experience here on Earth. So while the hype about 1 hour is wrong, the fundamental problem that Mars is just constantly being blasted with dangerous radiation is absolutely 100% real. So, okay, Mars is a lot. It's incredibly challenging. So what about our closest neighbor, the Moon? Is that an easier option, a better stepping stone? Well, this table really tells the story, doesn't it? The Moon is definitely not space colonization on easy mode. In some ways, it's even harder. It has basically no atmosphere, it's even drier than Mars, and the radiation is actually worse because there's nothing to block it. And instead of toxic soil, you get this stuff called lunar regolith. It's like microscopic, razor-sharp glass that just shreds everything. So yeah, in many ways, the Moon is an even tougher engineering nut to crack. So all of this leads to a really powerful, kind of logical question. It's pretty simple when you think about it. If we can't build a sealed, self-sustaining habitat in the harshest places here on our own planet, why on earth do we think we can just skip that step and do it on Mars? I mean, the logical engineering path seems pretty obvious, right? Step 1, build your sealed habitat and prove it works in the Sahara. Then, step 2, take that same gear and prove it can handle the insane cold of Antarctica. After that, maybe step 3, test it under the crushing pressure of the deep ocean. Every single one of these places is way, way more forgiving than Mars or the Moon, with breathable air literally right outside the door if something goes wrong. And that right there is the absolute core of the argument. Think about it. A habitat that's built to keep you alive on Mars should, by definition, work perfectly anywhere on Earth. If it can handle Mars, the Sahara should be a walk in the park. But we're not even trying that test. Nobody is. And the fact that nobody is doing these logical, common sense tests here on Earth, well, that tells you something really important about what the real priorities are. It actually brings to mind a cool concept from the world of economics. It's a concept called revealed preference. And the idea is super simple. It doesn't matter what you say your preferences are, your actions reveal what you actually value. It's like saying, I'm on a diet while you're reaching for a cookie. The action of grabbing the cookie reveals your true preference. Your actions speak way louder than words.
So let's apply that here. Just think about the technology you'd need for a Mars colony. We're talking about perfect water recycling, totally self-contained agriculture, complete energy independence. That technology would literally be world-changing if we used it here on Earth. It could solve water shortages, fix food insecurity, help billions of people. I mean, the logical first step, the one with the lowest risk and the biggest immediate reward, would be to build it right here.
So, that leaves us with a pretty tough final question. If this incredible, world-changing technology isn't being tested and deployed here on Earth, where it could help billions of people and would be easier to build, what does that reveal? What does that tell us about how ready the technology really is? Or maybe, what does it tell us about the real goal of this whole thing? That's something worth chewing on.